Hello everyone, this is Heading Tian. In this video, we will learn chapter 11.7, Events Involving and Conditional Probability. The first part is find the probability of an event and a second event occurring, and the probability with independent events. What's the independent events? Two events are independent events if occurrence of either of them has no effect on the probability of the other. That means, for example, the event A and the event B. The event A happened will not affect the occurrence of event B. Just like you flip a coin, first time you got a head, the probability of getting a head is 1/2. And second time you flip it again, and the probability of getting a head is still 1/2. So the first time you get a head will not affect the second time you get a head. Okay. What's the difference between independent events and the mutual exclusive event? We learned the mutual exclusive events before. That means the events cannot occur at the same time. That means you just have one time to do something, and the two events cannot occur at the same time. For example, you flip a coin just one time. So the head and the tail will not happen at the same time. Another example of mutual exclusive event is you run forward and you run backward. So these two events won't happen at the same time. And the independent event occur at different times, although they have no effect on each other. So these two events happened not the same time. Means twice. The event A happened once, and then I do the event B. The event A will not affect event B's result. The next part is the example. Example 1. When a fair coin is tossed 2 times in session, so that means we toss it 2 times. The outcome, the sample space is heads, tails, tails, heads, tails, tails. The probabilities with independent events. If A and B are independent events, then A and B, the probability of A and B equals P of A times P of B. If I want to know the P of head and heads, what's the probability of this? Because we mentioned about if A and B are independent events, so it equals to the P of heads times P of heads, because these two events are independent. We can use this formula. Equals, if you toss a coin, what's the probability of getting a heads? That's 1/2. And then getting a heads is 1/2. So the probability of if you toss coin 2 times in session to get 2 heads, probability is 1/4. Let's keep on going. The second example, independent events on a roulette wheel. A US roulette wheel has 38 numbered slots. 1 through 36, 0 and 0, 0. 18 are black, 18 are red, and 2 greens. So 2 greens are 0 and 0 and 0, 0 are 2 green. The ball can land on any slot with equal probability. What's the probability of red occurring on 2 consecutive plays? So the probability of the red occurring on 2 consecutive plays. So the first one is red, and the second one is red. These 2 events are independent, so it equals to P red times P red. What's the probability of this? Because we have 18 reds and the sample space number is 38. So that is the probability of getting a red is 18 over 38. And the second one is the same, is 18 over 38. Let's simplify this. Let's divide by 2 is 9, and divide by 2 is 19. 19. That is 81 over 19 times 19. The result is 81 over 360. It's about 0.224. Okay, let's move on. Oh, I have the solution here. Okay, example 3, independent events in a family. If 2 or more events are independent, we can find the probability of them all occurring by multiplying their probabilities. The probability of a baby girl is 1/2. So the probability of 9 girls in a row is what? Let's delete this. Add a question mark here. Okay, is what? If I want to find the probability of 9 girls in a row. The probability of 9 girls in a row, the first one is a girl. The probability is 1/2. The second one is still a girl. 1/2, 1/2. And then this part equals 1/2 to the 9th. So that equals 1 over 5/12. So this is not a hard question because each time you gave a birth to a girl, the probability is 1/2, and second time is still 1/2. So you multiply them together, you got the probability of getting 9 girls in a row in a family. Next question is example 4. The single dice is rolled twice, and the probability of rolling an event number of first time and a number even number. Sorry. So the first event A is an even number for the first time, and a number greater than 4 the second time. I'd like to list the sample space. The sample space should be 1, 2, 3, 4, 5, 6. This is my sample space. And rolling an even number, what's the probability of even number? I just use an E to represent the even number. The probability of getting an E is the number of even number. 2, 4, 6 is 3 over the number of sample space, that is 6, which one is 1/2. And what's the probability of getting a number greater than 6? That means greater than 4. I'm sorry, greater than 4. The probability of getting a number greater than 4 is 5, 6. we have 2. 2 over 6 is 1/3. So I'm looking for the probability of E and even number and the greater than 4. So I'm just multiply these two independent events, which is 1/2 times 1/3, which is 1/6. Let's move on to next question. Number 5. You draw one card from 52 card deck, then the card is replaced in the deck, and the deck is shuffled. What's the meaning of replaced in the deck? That means the first time you draw a card, and then they put replace the card you drawing from the 52 card deck, and right now it's still the 52 card deck. So you draw again. So these two events, two drawings are independent because the second time didn't change the sample space. So the question is asking, find the probability of drawing a queen the first time and a diamond the second time. The probability of drawing a queen, I use a Q to represent the event. Find the P of Q, drawing a queen at the first time. We have sample space number is 52. How many queens? We have 4 queens. And the second one, what is the probability of getting a diamond? I use a D to represent diamond. We have 13 diamond, 13 over 52. These two are independent. So the probability of first time is Q and second time is a diamond. I got 4 over 52 times 13 over 52. And we simplify this. 4, 52 is 13. 13 is 1 over 52. Let's move on to next example. Hurricanes and the probabilities. If the probability that the South Florida will hit by hurricane in a single year is 5 over 19, this is the probability of getting hit by a hurricane. Question is, what's the probability that South Florida will be hit by a hurricane in 3 consecutive years? So the solution should be in 3 consecutive years. The first year is hit by a hurricane. Maybe we can use, I already have the solution here. The hurricane for first year, the probability, P of a hurricane and times the P of hurricane, 3 consecutive years, and then multiply 5 over 9 and 5 over 9 and 5 over 9 together, we got the probability is here. And the second one, what is the probability that South Florida will not be hit by the hurricane in the next 10 years? So let's find the probability of no hurricane per year. That means we use 1 minus a single year's Florida will be hit by a hurricane. That is 1 minus 5 over 19 is 15 over 19. It's about 0.737. So in next 10 years, that means 10 consecutive years, first year, second year, third year, and to the 10th years. So we need to multiply all of these together. So P of not hit by hurricane in next 10 years, not I just simplify that, just use not 10 years equals 1 minus 5 over 19 to the 10th power equals 14 over 19 to the 10th. And it's probably equals, I should use a calculator. It's about 0.047. Okay, here is a good question. What is the probability that South Florida will be hit by hurricane at least once in the next 10 years? So if you see at least once in next 10 years, you will be confused. So what should I do? We should think about the negative way, because P of not E equals 1 minus P of E. That means will be hit at least once equals 1 minus never hit in 10 years. That means P of at least once, in 10 years equals 1 minus P of never be hit in 10 years. We have solved this probability in previous question, equals 0.047. That means we got 1 minus 0.047. So if you think you see the problem is hard to solve, think it's in the negative way. At least once in next 10 years equals 1 minus P of not being hit in 10 consecutive years. Okay, so here they give you a formula, the probability of an event happening at least once. The P of event happening at least once equals 1 minus P of event does not happen. Okay, let's see the next part. Probability with independent events. With dependent events. What's a dependent events? Two events are dependent events if occurrence of one of them has an effect on the probability of the other. So the event A happened will affect the event B's occurrence. And the probability with dependent events, they gave you a formula. If A and B are independent events, then here is the formula. P of A and B equals P of A times P of B, given that A has occurred. So based on the A's occurrence, find the probability of B's. Let's see from the example. The example 7. Elizabeth brought a box of donuts to share. There are 24 donuts in the box. All identical in size, shape, and color. 2 are jelly-filled, 7 are lemon-filled, and 15 are custard-filled. You randomly select one donut, eat it, and select another donut. Find the probability of selecting 2 lemon-filled donuts in a row. Before we learned if we choose the first one, we got the lemon-filled donuts. The probability should be how many lemon? 7 over the number of sample space is 24. And the second one, we can't use 7 over 24 because the first event happened. We already choose one lemon-filled donut, and then the sample space changed. It's not 24, it's 23. So based on the second one is lemonade. Based on we already took the first one is lemon, first lemon. The probability changed for the second time. We got how many lemon filled left? We have 6. So the number of lemon filled left is 6 over the new sample space is 23. So this is the probability of the second one is chosen is a lemon filled donut. The probability of selecting 2 lemon filled donuts in a row is P. The first one is L and second one is L equals the first one 7 over 24 times 6 over 23 equals 7. 4 is 92. 7 over 92. Okay, let's move on to next question. And the probability with 3 independent events is the same. 3 people are randomly selected, 1 person at a time, from 5 freshmen, 2 sophomores, and 4 juniors. And the probability that the first two people are freshmen, and the third is junior. So the first man is freshman. The probability of getting first man is freshman is the freshman's number is 5 over the sample space number. Sample space number of sample space equals 5 plus 2 plus 4, which is 11. So the first one we choose a freshman. Probability is 5 over 11. When we start to choose the second man, the probability of choose a freshman, given that the first freshman was selected first, equals, right now we have 4 freshmen left. The sample space become to 10, so the probability is 4 over 10. And the third one should be a junior. We already selected 2 people. So right now the sample space become 9. And from 4 juniors, we need to choose, we need to choose a junior from 4 juniors. That is 4 over 9. So you multiply them together, we got the probability is, the probability is 8 over 99. Let's move on to the part 2, compute conditional probability. We have seen that for many 2 independent A and B, probability of A and B equals P of A times P of B, given that A occurs. So how to use notation to denote it? Because I have this, I made this from my Windows laptop, so convert it to the iPad, it's delete a lot of information. Some of them cannot convert properly. So how to denote it? We use P probability P of A times P of B, and given this one, we said is given the condition of A occurred. So this is the conditional probability. So we can put it here. Okay, let's move on to see some examples. Finding conditional probability. A letter is randomly selected from the letter of the English alphabet. Find the probability of selecting a vowel given that. So this is conditional A. This is event A, I should say. Given that the outcome is letter at precedes H. Right now, how to express this? Because we are looking for P of vowel given letter precedes H. Right now, we need to find what's this part. This part, I still use sample space, is the letter precedes of H is A, B, C, D, E, F, G, without H because everything before H. Right now we have how many numbers in our sample space? 1, 2, 3, 4, 5, 6, 7. We have 7 numbers in 7 letters in the sample space. Okay, right now let's solve the problem. What's the probability of vowel given letter precedes H? Vowel is A and E, so the 2 out of 7, so 2 over 7. Let's move on to next part. The numbered discs shown are placed in the box, and one disc is selected at random. Find the probability of selecting an even number, given that the green disc is selected. Right now, they already gave us the second event is that the green disc is selected. That means we don't need to see the blue disc. So I cross them out. I just look at my green discs. So an even number, that means let's say the even number A is even number. And let's B be green. So the PA given B equals, so we have how many green discs? We have 5. How many even numbers? We only have 4. 4 number noted is 4. So the number of this kind of ball, kind of disc is 1. That is 1 over 5. Okay, let's move on to next question. Finding conditional probability. You are dealt 1 card from 52 card deck. Find the probability of getting a heart. Given the heart you were dealt is red card. So what is A? What is B? The probability of getting a heart. The heart means A. And given what? You were dealt a red card. We can let this part is B. So just note the event is first event A, second event B. You can also denote the first one is B, second one is A. It all depends on you. It doesn't matter. So we are looking for P of A given B. So the B event is the card you were dealt is a red card. How many red cards? We have 26 because the diamonds and hearts. How many hearts have 13 heart? So the probability is 1/2. Number B, find the probability of getting a red card, given that the card you were dealt is heart. So I denote A is this one, B is this one, B. The probability of my new A given B. So right now, the B, the card you were dealt is heart. How many hearts? You have 13. And based on the 13 hearts and how many red cards? We have 13. That means 1, since all hearts are red. So this is 100% that all the hearts are red card. Okay, let's move on to next example. Conditional probabilities with real-world data. This table are based on 100,000 US women ages 40 to 49 who participate in mammography screening to test whether they have breast cancer or no breast cancer. Assuming that these numbers are representative of all US women age 40 to 50, find the probability that women in this age range has a positive mammogram, given that she doesn't have breast cancer. So find what is A, what is B. The probability that woman in this range has a positive mammogram. So positive mammogram is here. Given that doesn't have breast cancer, so doesn't have breast cancer is here. So find A and B. This part is A, given part is B. P of A over B, A given B equals A. Oh, first we need to see the B. B part is doesn't have breast cancer. So the total number of doesn't have breast cancer is 99,200. 99200. And based on this, so if we already see the given part and we don't need to see other data, we just focus on no breast cancer part. So based on the given number of doesn't have breast cancer, how many women has the positive mammogram? The positive is here, is 6944. And then we simplify this result. The number is here. So this part shows us we can use the formula of conditional probability. That is P of B given A equals the number of P and A divided by the number of A equals number of outcomes common to B and A divided by number of outcomes in A. That means, look at here. First we need to identify what is the number of A. We already find it from our our table is here. And then what do we need to identify? We need to find the top part, N of B and A, the intersection, or that's a common of B and A. So we already identify what is B, what is A. So this part and this part, what's the intersection? That is here. So here is the intersection. You use this amount number divided by this. So that's what we are looking for. Okay, I think these are all about the chapter 11.7. If you have any question, please let me know. Thank you. Have a good day.